Hello and welcome. This video presents my personal workflow for making 3D prints using Autodesk Fusion 360 for the 3D design and drafting, Slicer for taking the 3D design and slicing it to make the G-code required by the printer, and then we'll be printing a 3D object on a Prusa 3D printer. What this video is not intended to do is to provide detailed instruction on any of those three operations. Really, it's just a quick overview of how the start to finish process flows. It's a video that I wish I had had when I first started 3D printing to take some of that mystery out of the workflow process. I hope you find it useful. With that, let's get started. What we'll be making today, for our example, are some tiny 55-gallon drums, scaled approximately for HO train layouts. What you see here are several drums used in a project I'm currently working on, that is a working underground mine. Most everything you see here in these pictures was actually printed on my 3D printer. We'll just be focusing on the drums themselves. So the first thing we'll do is design the drums using the 3D design software, in this case the Fusion 360. Fusion 360 is a really powerful program, and you can use it free for hobbyists, or as they call them, enthusiasts. I found it really simple to learn how to use to make basic objects, and yet it has many features you can add as your experience grows. So the first thing we're going to do is click on Create, and then we'll scroll down to Cylinder. Click on that and the drop down disappears. You'll now be able to choose a plane that you'd like to anchor your object. In this case, we'll choose the horizontal or XY plane, so left click anywhere on that. Now we can start our object anywhere on the plane. It really doesn't matter. I usually start at the center in order to make any subsequent measurements easier using the tick marks along the X and Y axis. So go ahead and left click on the center. As you pull the mouse away from the center, you'll see that it asks you for a diameter. Now, HL scale is approximately 3.5 millimeters per foot, and a common 55-gallon drum is 23 inches. If you do the math, it's pretty close to 7 millimeters. So we use that as our diameter. It's easiest if you just type the number 7 and then click Enter, once to confirm and a second time to lock the value. Now we can enter a height. As it turns out, 10 millimeters is pretty close to the scaled value of 34 inches that we want. So we'll hit Enter, and voila, we have a cylinder. Let's click on Home to get up close and personal with our drum, which doesn't look much like a drum yet. It's really just a cylinder. Now let's look at a top view, and then go over to Create again. This time we'll select Torus. Head to the center of the cylinder, left click anywhere on the top of the cylinder, then click again at the very center. Move the mouse away from the center and stop when you get to the edge of the cylinder, which matches our previous 7 millimeters. When you left click, a drop down menu will appear. Move to the torus diameter and enter a value of 0.5 millimeters. Now notice that the operation drop down says Cut, and also notice that the torus itself is colored red. We don't want that. We actually want New Body, so left click on that and then hit OK. So let's see what we have. Let's move the torus down the drum by right clicking somewhere on the grid and then left clicking to select Move Copy. Left click on our new torus and you'll see that it lights up blue. We can now grab the up down arrow and slide the torus down the cylinder. Let's look at a front view to help us see where to place the torus. Let's put this torus about a quarter of the way from the bottom, and then we'll click OK. Now we need to make another torus, so right click anywhere on the grid and left click Move Copy. Now click on the torus and you'll see that as before it turns blue. This time we don't want to move this torus, but we want to copy it. So click on Create Copy. And you'll notice that the OK button doesn't light up. That's okay. As soon as we start to move the torus, you'll see that the OK button does light up. So let's move our copied torus up. Looking at it, I'll drop it here. But now I don't like the symmetry of the lower torus, so we'll move that. Okay, that looks good to me. If you're really anal about these things, you're always welcome to measure things out and put the ring exactly where they should be. But I think generally for our purposes, this looks great. So our drum's looking pretty good. But it'd look even better if we drop the top down a bit. So let's click on the top view and go grab another cylinder. Let's place that on the drum, right in the center. Move the mouse and make the diameter 6.5 millimeters. Now let's push our new cylinder down into the drum about 0.5 millimeter. I like it. It now looks like a real 55-gallon drum. But we're not quite finished. We now need to attach the toruses to the drum itself. So move up to Modify, click on Combine, then click on one of the toruses. Then click on the drum itself and hit OK. Our torus is now attached to the drum. We'll need to do the same thing for the other torus. Okay, now what I really want to do here is to make two types of drums. One will be a closed top and the other will be an open top drum. With the open top, we can pour in an epoxy or whatever to add additional detail, like the spill drum here. So let's just copy the drum. And then left click on the top of our new drum. Then right click to pull up the menu. We want press pull. Let's drag the top down, say 2 millimeters. Click OK. Great. Our drums are looking good. Now before we finish, we need to think about how these little guys are going to print. You'll find that sometimes with objects that are tall relative to their diameter, they can get knocked over during printing. I like to add a little extra surface area to the bottom of the drums to make sure they hold on to the printer surface. The diameter doesn't much matter, and so I'm guessing from experience about 5 millimeters will do it. Now, my 3D printer is set to print the first layer at a thickness of 0.2 millimeters. So that's the thickness we'll use here. Just make sure to make the operation say join and not cut. And now let's do the same thing to the other drum. Okay, we're ready to get our drums out of the drafting department and into the slicing department. Click on Make and notice in the drop-down the default option is to a print utility. We want to ignore that, so unclick the checkbox for the output. Then click on one of the drums and hit OK. We'll save this one as closed top drum, and we'll save the other as open top drum. Then let's save our work to the Autodesk Cloud. You might want to save your work more often depending on the complexity, or sometimes you might not even want to save it at all if it's something simple. It's up to you. So once it's saved, we can see all the projects in the Show Data panel display on the left. It can sometimes take a bit for it to get saved to the cloud, but here we go. All right, we're ready to leave Fusion, but before we do, here's a look at a group of components for my Mind project. As you can see, Fusion360 is really a high-powered program. You can make all sorts of stuff like gears and doors and paneling and just about everything. So it is really high-powered. And it doesn't take long to get to this level to where you can make all this stuff. All right, let's move on to step 2. Get out of the 3D design, and then let's go convert our 3D objects to something the printer can use. Now, I like to use Slicer, specifically the one modified by Prusa. It works really well with our printers and can save the user just a lot of frustration. After we open our Slicer, I want to add both types of drums at one time. And let's do this twice for a total of 4 drums to print. When you do this, Slicer drops everything into the center of the plate, so it looks like we only have 1 drum. The easiest way to separate them is to click on Arrange. Sometimes that works pretty well, but in this case I don't much care for how the program arranged our drums. So I'm going to move them to my liking. Now, first thing, let's go change something. Go to the print settings and click on Skirt and Brim. I don't normally modify this setting, but I need to show you something very important, and that is the Live Z adjustment. I think probably 3/4 of the print problems I see on forums that I read could be easily solved by getting the extrusion height correct. And that is exactly what Live Z is for. So what we're going to do is add a few loops to our skirt to give us sufficient time to adjust our Live Z. So we're going to make 3 loops, and then we're going to set them about 10 millimeters away from our objects, and that'll give us even more time to do the Live Z adjustment. Now I'll go back to the plater. Over here you'll see lots of choices for filaments. I almost exclusively print using ABS now, specifically Hatchbox brand. I found the default Prusa ABS settings work perfectly for the Hatchbox as well. Now, just a note on ABS versus PLA. Most of us beginners start with PLA. It's easy to use and pretty darn forgiving. I found though that once I get better at doing the Live Z adjustment, I have near 0 problems printing with ABS, even though I haven't cleaned my print surface for months. With ABS, I can easily attach components together using acetone, and even more importantly, sometimes I can place the objects that I print with ABS in a hot car and they won't melt. So that's really my go-to plastic. Okay, we're going to leave everything else at default, and then let's slice away. I suggest you always look at the layers after you slice. You can often spot design errors and slicing problems by looking at the layers. So you can see the 3 skirts here that are going to print around. Then as we go up, you can see how the printer is going to be printing each little line. You can first see the open top drum. Over here on the left, and over on the right is the closed top drum. So you can tell that what's going to happen from the print. All right, so let's export our G code. And incidentally, the G code is nothing more than a line of codes that the 3D printer reads to know how to print. All the magic is really done here in the slicer. Now we'll save the file, which includes all 4 drums, as just drums. And then I'll actually move this file to an SD card later to be able to take out to the printer, but for now I'm just going to save it to my desktop. All right, now let's go out to the printer. So the first thing you'll note is that my printer is pretty cold. So I need to do a little preheat. And so we'll go to preheat. I'm using ABS, so we'll select that, and then we'll hit enter, and then we'll go do something else for a bit. Their default settings on the Prusa work really well for the Hatchbox. So I usually let my printer preheat for a good 15 minutes or so, even after it reaches the selected temperature. I like to have everything to be nice and toasty before I start printing. And it helps a little bit that my printer's in an enclosure. Okay, everything's toasty, so let's print. I have the drums file on the SD card, so we'll select that file and we'll get going. First, the printer will do the 9-point calibration. Then it'll come up front and squirt out a little plastic. This is the time to get ready to adjust the live Z. As the printer starts to print the brims, we want to adjust the Z to get the first layer just right. I do this every time I print, without exception. Prusa has lots of information on how to do this, so we won't spend any more time on it for now. You can see I ended up with a live Z adjustment of 0.275 millimeter. That's pretty typical for my particular printer. Now we'll just let it print and come back later to see how it's doing. Things are looking good. We can see the bottom ring now. Let's take another break. Okay, we're almost done. There it goes. The print head goes back into the corner. We've got our 4 little drums and the 3 brims around the outside of it. A little hard to focus in here. And so now we're going to remove those. These things are so little that I can really just remove them with my fingers. So I just kind of pull on it and that'll come right off. With the brim, that's a little bit harder. I wouldn't be able to get that off. So what I do is I've got a little spatula and I just push it under there. If I've got to push hard, I kind of grab the back of the plate to kind of make an opposing force so it doesn't damage the plate, and just pull that off and then pull the little drums off. And here's what our final drums look like. I usually print in white ABS, so I have a neutral background to paint from. You can use various plastic colors, but I really like the look of the paint, so that's how I do it. So there you have it. If you have any questions, please comment below and I'll do my best to get you an answer. Take care and happy printing.